Welcome to session 7 of the Lawson Fuse's Fuse Masterclass. Today, we're going to be delving further into Fuse standards. So, what information is actually in the Fuse standards? They basically contain every single specification and requirement that you need to design or utilise a fuse. The wide range of important information ensures the safety and reliability of fuses in electrical systems. It is the list of items you have to satisfy to ensure compliance, and these guidelines help ensure that fuses provide effective protection against overcurrent conditions, preventing damage to electrical systems and reducing risk of fire and harm to personnel. Some standards are split up into different sections, and there is a separate list of required parameters for each type of fuse. These are referred to as fuse systems. So, for example, within 60269-2, supplementary requirements for use by skilled persons, i.e. industrial applications. Boiler connections is Fuse System E. Offset blade contacts is Fuse System G. Wedge tightening contacts is Fuse System I. Of course, you'll know these as the Lawson Fuse's bolt-in, clip-fit and J-type components. Following are some examples of the format of the data within these particular sections of the standards. Dimensions. You get a diagram and a table of figures to cover all compatible sizes within this particular fuse system. Voltage ratings. The rated voltage will always be stated, normally for AC and DC. Current ratings. The preferred current ratings are shown. These are taken from yet another standard that gives a list of various preferred number systems. There are lots of these, and the standard you review will tell you which one to use. Power dissipation. The power dissipation or watts loss is generally specified. You are given a maximum value, but the target is always to beat it and make the value lower. Braking capacity. They always state the minimum braking capacity. This is also known as the interrupting rating, and this is the maximum current the fuse can safely interrupt without being destroyed or causing an electric arc for an unacceptable duration. For example, when a short circuit is applied. Utilisation category. This is generally default to the component you are designing or using, but if there is a required deviation, it will be stated. Time current characteristics. These are shown in a series of tables and graphs. The axes are current in amps against time in seconds. These graphs are always logarithmic scales to allow the full graph to be shown on one page. Conventional times and currents. These refer to specific values that determine when a fuse will operate under certain conditions. Conventional non-fusing current is written as INF. This is the maximum current that a fuse can carry for a specified conventional time without melting. The conventional fusing current is written as IF, and this is the current that will cause the fuse to melt within the specified conventional time. For the example table shown on the screen, a 100 amp fuse must be able to withstand a current of 1.25 times 100 amps, 125 amps, for 2 hours and not melt. You then apply a current of 1.6 times 100 amps, which is 160 amps, and the fuse must melt within 2 hours. I squared T values. I squared T is a measure of the energy required to melt the fuse element. It represents the thermal energy generated by the current passing through the fuse. The units of measurement are amperes squared seconds. It is measured at very short times under high short circuit currents. One of the values we have to comply to is the pre-arcing I squared T value. This is the energy required to start the melting of the element. The table shown shows the pre-arcing values for a fuse at 0.01 seconds, just to show the sort of values we are talking about. Note the values are in thousands. Markings. The markings of all fuses is tightly controlled and certain information must be given. An example of requirements is shown on the screen. We've already been through what the markings on a fuse mean. Lastly, the standards will always specify the test requirements for each component. What the test setup needs to be, dimensions of test fixtures, connections, and crucially, what results are expected. The standards don't tell you how to design and manufacture anything, but they do specify the dimensions, the performance required, and the individual characteristics required from the fuse. The image shows an example drawing of a test configuration. The list we have just been through is not exhaustive. There are other requirements for each type of component, but this list is of the main items that we need to consider. Okay, that's it for today's session. I hope you found it interesting. Next session, I will be looking at the Lawson Fuses data sheets, what data they contain and how we read them. Don't forget to follow, share and comment. Thank you. Bye.